Welcome to The Explainer. If you can write clean, logical code, then you already have all the tools you need to communicate clearly. So today, we're going to decode English grammar, but we're going to do it using the logic and patterns you already live and breathe as a developer. Let's treat language like a system, find its syntax, and make it work for us. Seriously, think about it. That same structured thinking you use to build an application, checking conditions, linking different ideas, explaining outcomes, that's exactly the same logic that underpins clear, effective communication. The core logic is identical. We're just swapping out, say, JavaScript syntax for English syntax. Okay, so here's the game plan. First, we'll look at conjunctions as logical operators. Then we'll tackle flow control using time clauses. After that, we'll nail down conditionals, the classic if versus when. And finally, we'll talk about referencing objects so you don't get any null pointers in your conversations. Basically, we're building a linter for our own sentences. Let's get into it. All right, first up, the basics. We're going to see how those simple little conjunctions you use all the time are, well, pretty much just the logical operators you use to control the flow in your code.
Okay, check this out. The mapping here is so direct, it's kind of beautiful. And is just your classic double ampersand. Both conditions have to be true. Simple, right? Now, but is interesting. It's also a logical and, but it throws in a negation. I bought a sandwich, but I didn't eat it. It's basically bought sandwich and not ate sandwich. And then you've got so and because. Think of these as your essential code comments. So tells you the result, and because gives you the reason.
This is a big one. Knowing when to use so versus because is crucial, especially in like a postmortem or a status update. You'd say, the server went down because of a memory leak. That's the root cause analysis right there, the why. Then the action item follows. There was a memory leak, so we're spinning up a new monitoring tool. That's the what's next. Getting this right makes your reports so much clearer. And look at this. You can chain these things together, just like in your code. It's not just one condition, it's two. It was late, and I was tired. This is literally just a complex if statement. If is late and is tired, go to bed. See? The logic is identical. Multiple conditions, one single action.
Okay, we've got our operators down. Now let's talk about controlling the flow. In your code, you're always managing the sequence of operations, right? Well, in grammar, we do the exact same thing, just with time-based clauses. Seriously, just think of these as life cycle hooks for your sentences. Before is your precondition check. Before you go out. Run this function before the main event executes. While is for a concurrent process. It began to rain while I was waiting. Something happened while the main thread was still running. And after is your post condition. It's the cleanup, the follow-up, the thing that happens after the main event is done. Okay, now here's a key syntax rule. This is like a classic linting error that a lot of people make. When you're talking about a future event that depends on something else happening, you state that condition in the present tense. So you wouldn't say, I'll merge the PR when the tests will pass. Nope, you say, I'll merge the PR when the tests pass. Getting this little detail right is so important for creating project timelines that everyone actually understands.
All right, pay attention to this next one, because this is huge, especially when you're writing tech specs or user stories. The difference between if and when can literally be the difference between a feature and a bug. Get this wrong and you're opening the door to a world of pain and scope creep. So let's start with if. This is your bread and butter conditional. It's all about possibility. The code inside your if block might run, or it might get skipped entirely. It all depends on a condition that is not guaranteed. Think about it. If the API returns a 404, then display an error message. The error might happen. It might not. When, on the other hand, is totally different. It's not about possibility. It's about certainty. It acts like an event listener, or maybe a .then on a promise. It's for something you know is going to happen. For example, when the component mounts, fetch the data. The component is going to mount. That's a guaranteed part of its life cycle. So let's put them side by side. If I'm late, that's a maybe. When I get home, that's a definite. Now let's bring it back to our world. You'd say, if the API call fails, then trigger the retry logic. But you'd say, when the build completes, send a Slack notification. The build will complete, one way or another. The event itself is certain. So remember, if for maybes, when for definites. All right, last section. Let's talk about defining our variables, or, our objects.
This is super important because it's all about making sure our pointers are pointing to the right address in memory, so to speak. We want to avoid those dreaded null pointer exceptions in our conversations.
So if you just say, the man phoned, what does that even mean? It's like declaring a variable without initializing it. Your listener, who's acting as your compiler here, has to throw an error and ask, wait, which man? Can you specify? It's a totally ambiguous reference that needs to be resolved. And here's how you fix it. Watch this. By adding that little clause, who phoned, we've just provided a unique identifier. We're not talking about some generic man object anymore. Nope. We are pointing to a very specific instance. Boom. Ambiguity resolved. And we can take this even further. This sentence here is basically a class definition. You're not just pointing to an object, you are defining its core properties and methods. It's just like saying the class thief extends the person class and implements the steals things method. It's a blueprint. And hey, here's a super simple cheat sheet. Think of it as type checking for your sentences. If you're referencing a person type, use who or that. If you're referencing a thing, a generic object, use that or which. It's a really easy way to avoid type errors in your everyday language. So let's wrap this all up. The big takeaway is that grammar isn't some dusty, arbitrary set of rules. Not at all. It's basically the operating system for language, and its core logic is something you, as a developer, are already a master of. We've seen how and, but, and so are just logical operators, how if, when, and before are just flow control, and how who, which, and that are how we define our objects. So why does any of this actually matter? Well, because using language with this kind of precision leads to better documentation, clearer requirements, and way fewer arguments during code reviews. Ultimately, it just makes your team more efficient. Precise language literally prevents bugs in understanding, and that saves time, money, and, let's be honest, a whole lot of sanity. And that's it for this explainer. I'll leave you with one final thought to compile. If language is really the original API for the human brain, what bugs are lurking in your own communication? It's something to think about the next time you're writing a commit message, a technical doc, or even just a quick Slack message. Thanks for tuning in.